Thanks everyone for coming. The newcomers, if you want to move front, there's still plenty of space in the front, just in case you fancy. Okay, we're going to talk about data science and in the humanitarian response context. So a little bit about what we coined recently as outbreak analytics. What's that fancy term about? It's basically emerging data science that we've seen like taking off over, say, the last 5-10 years. And the aim of these data science is to try and inform the response to outbreaks of diseases, typically nasty diseases in places where controlling new outbreaks is going to be difficult. So it's a mixture of a lot of things, like all of the data sciences, right? So you've got some statistics in there, some software engineering, some database infrastructure, and some other things are like more specific to the field itself. And it's a bit of a weird field as well, because it's at the crossroad, essentially for now, between academia and public health institutions. So there's not a school of outbreak analytics you can go to learn the ropes of it. One of the things that we noticed, I think, back in 2014 when we were involved in the response to the West African Ebola outbreak, probably all of you heard of it, because that was the largest Ebola outbreak in the world, still is to this date. We realized there was a big lack of tools. So at the time, a bunch of scientists were trying to understand what was going on and make predictions to inform public health institutions like the World Health Organizations, but a lot of tools were missing. So that's what led to the creation of something called RECON, the R Epidemics Consortium. So it's not the R Consortium, it's R Epidemics Consortium. Don't just Google RECON yet. It's a different community. So don't go to recon.com just yet. The website is repidemicsconsortium.org. There's a QR code at the end of these slides, so you can get the slides, you've got links and etc. So you don't need to remember anything for now. And so it was basically something that emerged in the aftermath of a hackathon that was called Hackout 3 that we co-organized with Karthik Ram from the R Open Sci in Berkeley. And it led to basically what is now an NGO. It's been in existence since last September, so it's a fairly new NGO. We've got around 35 members and 200 to 300 followers, subscribers. And I think currently that may be the largest initiative for free open source tools for outbreak analysis that there is, and it's all based in R, hence the R Recon. So there's a bunch of things we've been trying to do besides software development. A lot of it is training, so we've been running a lot of workshops, a lot of short courses, and we keep trying to do that. And another thing is deployments. And we don't do deployments ourselves directly, but we try to be part of deployments with partners. And this is something still fairly new, so there's not been many of these so far. Actually, I think this one is the second I'm aware of. So this is about the second largest Ebola outbreak in the world. Just a show of hands, who's heard that there's an Ebola outbreak going on for nearly a year in Congo? Hands up, don't be shy. Right, it's like about a quarter of the room. That's kind of concerning because it's a terrible outbreak. Second largest in recorded history, largest in Congo. And it's a very tricky situation. Ebola is a terrible disease. It kills around 60 to 70% of the people that are contaminated. It decimates families. It's really a horrible disease, right? Now, on the top of that, this is now happening in North Kivu and Ituri, which is historically an area which is a zone of conflict, of armed conflicts. There are several armed groups in there. Got one of them here. So it's a very tricky situation, and it's been a very difficult response from the very beginning, and it's still ongoing. It's not over. So I was there. Since February. I've been spending 4 months in total as part of this response. And my job there was to set up a data pipeline, if you want, an analytics infrastructure to inform the response in real time. So I'm going to tell you a little bit about that. What are the aims? So that's what we call the cell, the analytics cell. What were the aims and the challenges of the cell? So first challenge is data is messy. We all know that. We've all dealt with messy data, but this is particularly the case. There's a lot of different data sources. You need to update your analysis almost on a daily basis, sometimes on a daily basis, and all of your data sources are not really coordinated in terms of their updating, in terms of their structures, so it's a mess. There's pretty much all the needs you can think of, except for maybe artificial intelligence or big data problem. There's almost all the needs you can think of in terms of data science, from the non-glamorous but still important data cleaning all the way to fairly complex forecasting models and Bayesian methods, right? So we really need to have like quite a wide array of tasks to do. Some of them we're going to have to do every day. These are the routine analyses. Some of them are going to be on an ad hoc basis. So whatever infrastructure we come up with, we need to be a bit flexible because there will be new questions pretty much every day. And then we need an audit trail to be available. So we need everything to be reproducible, right? So all the reproducible data science arsenal needs to be in place. And on top of that, you've got field conditions. So think bad internet, terrible internet, or no internet. Any platform you can think of, different versions of Windows, Mac, Linux, and overall a low computer literacy and almost no previous knowledge of R, which in terms of training staff on the ground is going to be a challenge as well. So whatever we're going to be doing, want to make it as automated and simple as possible. So I'm going to show you a little bit, tell you a little bit about this infrastructure. This is more or less a complete overview of our routine analysis. There's in total, I think, about 20 different reports. All of these different tasks are different bubbles, and the size of the bubble is more or less a reflection of how complex, how many lines of code, how complex it is, yeah? So there's a lot going on there. All of these are actual results generated during the outbreak. Clearly, I'm not going to have time to go through all of this, and you'll be bored by the end of it. I'm going to touch at the central part, the infrastructure part. This is the Tidier R markdown bits. Then I'll talk a little bit about data cleaning, and if I have time, very quickly about how to take R to the field where there's no internet. I'll go quickly over this. This is like the agenda, the original agenda of what ended up being called the report factory. It's an R package that we've developed about a few months ago, and I'm going to go into some examples of this, but I won't read all of these. Basically, what we wanted to do is be able to handle a bunch of R markdown documents, which can have different versions, and want to be able to have the bookkeeping done for us. So every time outputs are generated, we want them to be put in a safe place, like time-stamped and all well sorted. Basically, we want to have some of the advantages of having version control without going the whole way with like Git or that kind of version control systems. One of the important thing here that I want to point out is non-invasive. We don't want the system to impose anything on the user, so we want to be able to use standard R markdown documents. You just take your usual R markdown, dump it in the right place of the report factory, and then the factory will be able to process it. So that's how it works, just taking the example of one type of documents and one topic of analysis. You could have like 10 of them. And the idea is the following. You've got different colors on the right-hand side. These are different time-stamped versions. So they're just different versions of your document, right? But you want to keep them because you want that audit trail. And the idea is every time you're going to compile your document, this is going to be stored on the right-hand side on a folder matching exactly the name of your report. And then you would have subfolders in there storing information outputs by date of compilation. So it will say, this document's been compiled on that date, that hour, minute, and second. So you've got a full audit trail of what's been produced in there. There's a few other features, we'll come back to this. So a report factory is not super complicated as a structure. It's just a bunch of files and folders. You can create it by saying report factory, : new factory. That will create that. So basically, a couple of folders. The most important one is called report sources. That's where you put your RMD files, right? And you can have any substructures in there, any nesting of folders you want. And then all the rest is going to be pretty much taken care of for you. The outputs are going to be stored in the output folder. You've got R project shortcut that you can use to open a session in the right environment if you use RStudio. And you've got an anchor as well using here because we want all the files to be referred to with respect to this anchor. That's basically, for those of you who've used here, it's going to be very, very useful in terms of portability and being able to just move your files across and not having to redefine the path to the data and the scripts and so on. There's some other features we take care of, listing dependencies, scanning through all the R markdown files, and you can install the dependencies that are missing and a bunch of other things. Long story short, this is still under development. It's functional, it's been deployed to the field, it's the backbone of our infrastructure, it works decently, but it's open to the community. And because it's a more general problem than just epidemiology, really your feedback or contributions are very welcome. We're not quite ready to put it on CRAN yet, but it's on GitHub and quite functional. And I kind of lied, we don't have cookies for now, but we can make that happen. Right, cleaning. And I've got 5 minutes, is that it? Thanks, Chairman. So, data cleaning is not glamorous, but it's been the bottleneck. So you may end up using a very fancy Bayesian estimation method in some given package, but the thing that's going to break down your infrastructure is actually the data cleaning step. It's that variable that's been misnamed, or now it's all uppercase and it used to be lowercase, or now there's an accent somewhere in there, or some values of your levels of your factor changed just because of new misspelling. And granted, in an ideal world, you've got a well-curated database, and none of this is happening, but actually the data typically looks like this, and I've seen a lot worse. So the idea was to have in the package line list, which is like a line list is typically an Excel spreadsheet with cases of a given disease. That's what we call line list in epidemiology. And so line list clean data will basically do that basic round of cleaning for you. And you can see an example here. What it does is it's gonna like lowercase everything. It's gonna replace all the accentuated characters by the closest match on the ASCII table, move everything to ASCII, remove all the extra separators, replace standardized separators to be whatever you defined it to be by default underscore, and it will guess dates as well. Actually, currently it guesses dates better than lubridates, which it partly uses in the background. But if you look at the messy date column in there, you can even detect automatically the date format. So that's like all done automatically for you, and it will detect and fetch the date from this. Another type of cleaning which has been proved really useful is to use a cleaning dictionary, right? So that's the rules that you see in the pink box. You've got a mistake, a typo typically, a correction, and which variable this applies to. The good thing about this is that you can actually have this cleaning rule in a separate Excel spreadsheet, and people don't need to know R to be able to fill it up, which means that you can actually use like all the data cleaning, most of the data cleaning can be outsourced just by filling an Excel spreadsheet. And then your system just integrates it automatically. And that also makes the rules, the cleaning rules, universal across different reports. So you don't have different versions of your data set in different analyses. All right, very quickly, what do you do if you need to teach and you're not quite sure there's going to be internet in your teaching place? Well, it's kind of like the same situation that going to the field and there's only a VSAT that's very expensive and very low connection bandwidth. So you want to put everything on a USB stick to the extent that it's possible. That's what we've done with what we call the Recon deployer, which actually piggybacks on Rich's package called Nomad, which is, it basically contains three types of things. First, the latest version of R, RStudio, Git, R tools for the different platforms, so Linux, Mac, Windows, some cheat sheets, and more importantly, a local CRAN-like repository of like 2,000 to 3,000 packages. One of the good things about this is we actually can put any GitHub packages in there as well. And it's been very handy. We've been using it like now, this approach for maybe 2 years. It really works decently, especially when you have a lot of teaching to do with a bunch of people that all have different computers. It's really handy to make sure that everyone's got the same R version and the same R packages without having to go like full-blown Docker infrastructure. Right, so why am I telling you this? And does it serve a purpose? Long story short, yes, and I was myself surprised by that, but actually we can do useful things by looking at data because that's how we inform the operations, and we can do that in real time if we're in the field. This one, I won't go through the whole story, but basically shows that there's been a decline after an intervention, which is the pink line you see here, a decline in the number of cases in one of the hotspots called Butembo. So these are numbers of cases. And what we've shown with this was that actually the strategy was working because it brought transmissibility under the critical threshold of 1, whatever that means in this case. And we could derive projections to like forecast the expected number of cases that we'd see there, showing that it was working. And now this strategy has been they're trying to implement it in different places as well. Right. The last one to say, join us. One of the things that we are missing is you guys. We are really struggling to find good data scientists that are interested in humanitarian work, probably because it's just emerging. So by all means, if you're even partly interested in any of this, your skills are going to be useful. And there's a lot of good things about that. You know, you've got a purpose, you can measure the impact of what you're doing, you can travel to exciting places. There's a lot of exciting data challenges as well, and a lot of potential for capacity building. We've been talking about this, like how do we take like R and data science into LMICs? Well, that's a good way to do some capacity building. And with this, thanks to all my colleagues, are still some of them in DRC. If you want these slides, you can scan the QR code and that should take you through the slides. Thanks for your attention.
We have time for a few questions for Thibaut. Okay, I'll ask one. How did you find people with no experience to R sort of got involved with using it? Did they enjoy it, or did they find it a complete chore?
Yeah, that's a crux of the problem, right? If we get them interested, then things will propagate. Actually, it's been great. We've been training, I didn't count, but maybe between 10 and 15 people when I was there, with various levels of computer literacy, from people that had a data more or less scientific background or computer sciences background, from people that weren't quite sure how to unzip a file on Windows. And it's been really good. The thing that draws them in is when they see that it can actually make their lives easier. So the clean data stuff, it's not glamorous, but when you do that manually or on Excel, that actually helps quite a lot. The whole automation, so R markdown, the report factory, people can use it with one command line. Typically what people need to do currently, that's what they're doing. They double click on the open R project file, say update reports, it will update all the reports they need for basically their presentations and their communications. So it's not trivial because it's still quite a steep learning curve, but they see quite quickly that it can actually be useful to them. And there's a lot of enthusiasm for short course and training there.
So thanks, it was super interesting. Are you in contact with the local universities to maybe see if you can implement an R course in the base, or even in France, where these people, they get trained in France, to see if they could get trained specifically to R and not to Stata or SAS or any other software, which unfortunately happens still?
Yeah, so not universities as of now. The Ministry of Health is keen. The World Health Organization, the Afro Region Bureau wants a workshop. We've done one already in Benin before. So they're super keen on that kind of stuff. And I think some longer term capacity building plans. With universities, as of now, no, but that's definitely also like a possibility. Yeah.
Cool. Thank you very much.
Thanks, guys.